Hello students, good evening. Today in this video I am going to explain the preparation methods of alkanes. Okay, in the previous video I explained the introduction to the alkanes. In that I covered nomenclature and the isomerism. Okay, so in brief we'll discuss in the GOC. Okay, brief explanation about the nomenclature and the isomerism we'll discuss in the GOC. While telling the GOC topic, I'll explain the again nomenclature of all the compounds. Okay, and isomerism how to write. Okay, those points are all we'll discuss in that GOC. Okay, now continuation to the alkanes. So in this now we are going to discuss preparation methods. The preparation methods, first one from unsaturated compounds. From unsaturated compounds. Okay, simply from alkenes. Alkynes also we can prepare from alkenes first. Okay, so from alkenes how we can prepare alkenes. Okay, so what is the difference between alkenes and alkanes? Two hydrogens only. So simply if you add two hydrogens, okay, simply if you add two hydrogens, you'll get the alkanes. Okay, so sometimes it is also known as hydrogenation. Okay, catalytic hydrogenation. Okay, so if you take one alkene, first suppose ethene. Ethene means CH2 double bond CH2. This is ethene. Here IUPAC names also important. Sometimes they will not give structure, they will give names. So if they given names also you have to write answer. So that's why you have to learn the IUPAC names also. So ethene are reaction with the hydrogen molecule in the brains of some catalysts like NIPD, PT. So the brains of these catalysts, if you heat, okay, so alkenes are heating with hydrogen in the presence of NIPD, PT. What is happening? Simply by breaking the one pi bond. By breaking the one pi bond, one hydrogen to the one carbon and another hydrogen to the other carbon will be added. That here one bond we are breaking now, so you have to write only one bond in between the CH2 and CH2. Okay. Next one hydrogen is adding now, CH2 will become CH3. Here also hydrogen is adding now, CH2 will become CH3. So what will get? Ethane will get. Okay, so ethene or hydrogenation, what will get? Ethane. Okay, so if you take propene, first suppose CH3, CH double bond CH2. Here also, if we add H2 in the place of same catalyst. Here also from this one hydrogen to this carbon, one hydrogen to this carbon will be added. Then what will get? CH3, CH2, CH3. So this is propene. Propene. If you take propene, what you are getting? Propane. What you are getting? Propane. Similarly, if you take bond line structure also, first suppose this is one butene. 1, 2, 3, 4. So at first position double bond is there, so one butene. Okay, if you take one butene, this is also one hydrogenation. Okay, the given bond line structure, simply you have to remove the double bond. Simply you have to remove the double bond. So if you remove the double bond, what will get? Butane you will get. Okay, butane is giving butane. If you take two butene also, if you take two butene also, okay, here if you take this one, 1, 2, 3, 4. This is also on hydrogenation in the presence of same catalyst. Okay, in the presence of same catalyst. Here also what will get? Here also the double bond you have to remove. So here also we'll get a butane. Okay, here also we'll get butane. Next, if you take the cyclic compounds like suppose cyclopentane. Okay, cyclopentane. This is also on hydrogenation. What will you? Cyclopentane. Will you? Here also we are adding hydrogens. Actually here double bond means CH only. Here single bond means CH2. This we can write like this also, CH2, CH double bond. Okay, CH and here CH2, this one. So this structure both are same only. This is cyclopentane. This is also cyclopentane. Here if we add hydrogens, okay, here by breaking the one pi bond, here, okay, from this here one hydrogen, you have to add. Then what will get? CH2, CH2, okay, CH2, CH2, here also CH2. So in this way, this or this, okay, this or this. Cyclopentane, if you take the cyclopentane, you are getting cyclopentane. Simply here, what is happening? E is converting into A. Okay. So to the alkenes, if you have hydrogens in the presence of NiPDPT, what is happening? E is converting into A. Okay. Next here, if suppose sometimes they'll give only cyclopropane, this is hydrogenation. This is alkane. This cyclopropane is alkane. Even though it is alkane, this is unstable alkane. Okay, unstable cycloalkane. So here also what is happening? Cycloalkanes formula, alkenes formula both are same. Cycloalkanes, alkenes formulas both are same. CN, H2N. Okay, cycloalkanes, alkenes formula same. So cyclopropane hydrogenation simply here 3 carbon containing cyclic ring. So if here ring opening takes place, taking place means you get cyclopropane. Okay, 1, 2, 3. So 3 carbon containing cycloalkane you will get. If you take cyclopentane, here also hydrogenation takes place. Then what to get butane you get. Next cyclopentane. This hydrogenation will give no reaction. Here it will give no reaction. Why? This is stable. Okay, if you take the cyclohexane, here also it will give no reaction. Why in these two cases no reaction? In these two cases open chain compound is coming, because these two are more stable than this one. Okay, if you see the stability order of cycloalkanes. Okay, if you see the stability order of cycloalkanes, cyclohexane more stable than cyclopentane, than cyclobutane, than cyclopropane. So these two are stable, so that's why they will not give the reaction. These two are unstable, so they are highly reactive, and they will easily undergo hydrogenation and give open chain compounds. So this is about the first preparation method of alkanes from alkanes. Okay, from reduction of alkyl halide. Okay, so here alkyl halide is represented as Rx. R means alkyl group, X means halide. Okay, so reduction of alkyl halide. Okay, so here if you take the alkyl halide, okay, what is happening here? Also addition of hydrogens takes place. Okay, here reduction means in organic chemistry addition of hydrogens. Okay, reduction means addition of hydrogens. Okay, so if you take 2 hydrogens, because one bond only you have to break, so that's why you have to take 2 hydrogens. In the presence of which one over here, so many catalysts you can take. If you take zinc plus acid, means zinc plus HCl. Okay, zinc plus acetic acid, zinc plus base. Okay, zinc plus base, zinc plus zinc plus Cu. Okay, at the same time, along with these LiAlH4. Okay, lithium aluminum hydride. Okay, simply you can write LaH short form of lithium aluminum hydride. Okay, and next one triphenyl tin hydride. Okay, triphenyl tin hydride. Okay, so simply we can write TPH. Okay, triphenyl tin hydride. This also will give the alkanes from the alkyl halides. At the same time, next NaBH4. Okay, NaBH4 sodium boron hydride. Okay, next magnesium in the presence of dry ether. Okay, followed by hydrolysis. Okay, followed by hydrolysis. So all these all catalysts they will give alkanes from the alkyl halides. They will give alkanes from the alkyl halides. Here what is happening? Here you have to break the Rx bond, means carbon halogen bond you have to break. Here R means alkyl group. Alkyl group means carbon containing compound. So this you have to break. So after breaking this one, hydrogen to the last carbon. To which carbon this bond is attached, to that carbon only you have to break you have to add the hydrogen. Next, one more hydrogen to this halogen. Then what will get? RH. RH plus HX will get. This is a alkane. So in this way, you will get alkanes from the alkyl halides. Okay, if you take any alkyl halide also, for suppose CH3, CH3Cl. Here what is happening? So this is all hydrogenation in the presence of any one of these. Any one of these. Okay, here you have to break this bond. One hydrogen to this one hydrogen to this one. Already it is CH3. One more added means it will become CH4 plus Cl. H is added means HCl. Okay, by using this reaction we can prepare methane. We can prepare methane by using the reduction of alkyl halide. In the previous method, from alkanes we are preparing alkanes. Now in that method we cannot prepare methane. Why? Because alkene means minimum 2 carbons. Okay, alkene means minimum 2 carbons. So from ethane onwards you can prepare, but you cannot prepare methane in that first method. Here we can prepare from methane onwards. Okay, next if you take the CH3, CH2, Cl. Okay, Cl or Br also you can take. If you take Br, bromide, ethyl bromide, this is methyl chloride is giving methane. Next this is ethyl bromide. Ethyl bromide. This ethyl bromide, I am hitting with any one of these in the brain and hitting with any one of these. What is happening? Hydrogenation takes place here also. Then what will happen? Here one hydrogen. This bond you have to break here. This bond you have to break. One hydrogen to the this carbon. Okay, one hydrogen to the this carbon and one hydrogen to the this Br. Then you have to add them. Already it is CH3, CH2. Okay, to the CH2 one more hydrogen is added. Then it will become CH3, CH3 plus HBr. Okay, CH3 plus HBr. Okay, similarly, if you take a bond line structure for suppose. Okay, here iodide, alkyl iodide. Here also if you add hydrogens, two hydrogens if you add. Okay, here also if you add two hydrogens, what is happening? Here 3 carbons only it is having. Okay, 1, 2, 3. This carbon attached to the iodine. So here this bond you have to break. Okay, so this bond you have to break means this hydrogen here and this hydrogen here you have to add them. This is propyl iodide. Now you will get propane plus Hi. You will get propane plus Hi you will get. Okay, so in this way you can prepare the alkanes from the alkyl halide. Okay, so this is a second method. Right, next examples are over here. For suppose here, if you are getting one alkane means the corresponding alkyl halide is the starting material. Okay, they can ask question. If suppose here butane is a product. Okay, butane is a product. What is the starting alkyl halide? What is the starting alkyl halide? It may be 4 carbons containing alkyl chloride, or alkyl bromide, or alkyl iodide. So here in this reaction, you have an alkyl halide reaction with G plus acid. It gave butane means what is the starting material? What is that alkyl halide asked means? Here initially, what is the starting material they asked means? Here how many carbons containing alkene you got? Same carbons containing alkyl halide you have to take. Okay. So here 2H, one hydrogen to this carbon and one hydrogen to this carbon. This bond you have to break here. Okay. So in this way, if you add up, here HCl will be eliminated. The butane will get. Okay. So in this way, from the reduction of alkyl halides, you can get the alkanes. Okay. So here we'll discuss one small reaction. Third one, from metal carbides. Okay, from metal carbides. If you take the L4C3, okay, beryllium carbide B2C, magnesium carbide Mg2C, and calcium carbide CaC2. So these carbides are hydrolysis. Okay, what will get? Methane will get. Here methane only will get. Here how many carbons are there? 3 carbons, so 3 moles of methane. So 3 moles of methane means how many hydrogens? 3 4s are 12. So 12 H2O molecules you have to take. Okay, 12 H2O molecules you have to take. Okay, then remaining OHs all will be removed as AlOH thrice. So okay, I'll be removed as 4 moles of AlOH thrice. Similarly here also, this are hydrolysis also. Here 1 carbon only, so 1 methane only will get. How many carbons? 4. So 2 moles of H2O you have to take. Okay, 2 moles of H2O you have to take. Okay, so here 4. So 4 moles of H2 you have to take. So BeOH twice. And here how many Be atoms are 2. So 2 Be atoms. No? So 2 moles of BeOH twice will get. Here also 1 carbon only in the magnesium carbide also. So methane will get. Okay, 4 carbons now. So 4 moles of H2O. So here what will get is MgOH twice will get. Here how many Mg atoms are 2. So 2 MgOH twice will get. Okay. So in these three cases, you'll get methane. So aluminum carbide, beryllium carbide, magnesium carbide, they are giving methane. But CaC2, calcium carbide will not give methane. Calcium carbide on hydrolysis, calcium carbide on hydrolysis, it is giving alkyne. Okay, CH triple bond CH, simply C2H2. Okay, formula is C2H2, alkyne it is giving, and the remaining part will be removed as remaining part will be removed as CaOH twice. Remaining part will be removed as CaOH twice. Okay, so in this way, alkane will get. You have to remember which of the following carbides will not give methane. The last question. CaC2 is giving alkyne, not methane. Okay. Fourth method, very very important one, Wurtz reaction. Okay, Wurtz reaction. Wurtz reaction means what? Alkyl halides. Alkyl halides. On heating with the sodium metal. Alkyl halides on heating with sodium metal in the presence of dry ether. Okay, alkyl halides on heating with sodium metal in the presence of dry ether. What is happening? Here you will take 2 moles of alkyl halide. So from the 2 moles of alkyl halide, 2 halogens, and this Na will be removed as 2 moles of NaX. 2 moles of NaX. Next here, how many alkyl groups are there? 2 alkyl groups are there. So 2 alkyl groups, if they connected, alkyl group. Okay, so both are connected with bond means, okay, what you get? Alkane you get. Which alkane? Higher alkane. Higher means more carbons. Here one carbon present means here 2 carbons containing alkane will get. Okay. So in the Wurtz reaction, okay, carbon bond is forming. You have to remember in which of the following reactions new carbon bond is forming. The last question. So in the Wurtz reaction, carbon bond is forming. Okay, because one alkyl group is connecting with another alkyl group. Okay, right. If you take examples, CH3Cl heating with the sodium metal. Okay, so if you take 2 moles of this one, then what will get here? 2 Cl atoms, 2 Na. Both will be removed as 2 moles of NaCl. Next here, 2 CH3 groups left. 2 CH3 groups combined means what will get? Ethane will get. So if you take methyl chloride, what you are getting? Ethane you are getting. Okay, double the number of methyl means 1 carbon. Ethane means 2 carbons. So if you take 1 carbon containing alkyl halide, double the number of carbons containing alkane you will get. Okay. Similarly, if you take ethyl bromide, for suppose CH3, CH2, these are heating with the sodium metal. So presence of ether. Here what is happening? Here also this part will be removed as, okay, this part will be removed as 2 moles of NaBr. Then here 2 alkyl groups are there. 2 alkyl groups are there. So 2 alkyl groups, which alkyl group here? Ethyl. 2 ethyl groups are there. So 2 ethyl groups joined. This is one ethyl group and this is one more ethyl group. So 2 ethyl groups are written later in between them I written a bond. So then it will become which one? Butane. If you take ethyl bromide, what you are getting? Butane. Okay. We will ask questions like butane is obtained by Wurtz reaction, then what is the alkyl halide? Okay. So what is the alkyl halide? Ethyl halide. Ethyl bromide it will be, ethyl chloride it will be. Okay. Right. Next one, if you take the bond structure on example, for suppose propyl bromide are heating with sodium metal. Okay, so this is the N-propyl bromide. So here you have to break. Okay, so 2 moles if you take, here also 2 Br atoms and 2 Na, both will be removed as 2 moles of NaBr. Then here 3 carbons are there. Okay, so here 3 carbons are there. And here also I written 3 carbons. Okay. So here 3 carbons are there. Okay, so here also I written 3 carbons. Okay, in between them, what you have to write? You have to write one bond. Then how many carbons? 1, 2, 3, 4, 5, 6. Hexane will get. If you take propyl bromide, if you take propyl bromide, what you are getting? Hexane you are getting. Hexane you are getting. If you take isopropyl bromide, for suppose, here we discuss. If you take isopropyl bromide, for suppose, this are heating with the sodium metal. Okay, this are heating with sodium metal in the presence of dry ether. What is happening here? Two isopropyl groups you have to write. Later, here Br will be removed, here also from here Br will be removed. These two have to connect. Then 2 moles of NaBr will get. What is the name of this compound? 1, 2, 3, 4. At second, third position, substituents are there. Methyl group. One carbon only here. So methyl. So 2 methyl groups are there. What positions? At the second and third position. So 2, 3 dimethyl. Dimethyl and the longest and 4 carbons are there now. So butane. So in this way, if you take isopropyl bromide, you will get a 2, 3 dimethyl butane. If you take the propyl bromide, what will get a hexane will get. Okay. The next very important one is by using the wurtz reaction, we can prepare odd number of carbon containing alkanes or not. We can prepare odd number of carbon containing alkanes or not. That is the question. Okay, we can prepare. Okay, we can prepare odd number of carbon containing compounds also. See here, if you take the CH3Cl, okay, if you take the one more alkyl halide CH3CH2Cl, both are heating with 2 moles of Na in the presence of dry ether. Okay, previously 2 moles we took same. Okay, previously we took 2 moles, same alkyl halide we took. Now we are taking different alkyl halides. One alkyl halide methyl chloride, other one is ethyl chloride. In these two cases, what is happening? First if you take 2 moles of CH3Cl, or for suppose if you are taking 1 mole of this one, 1 mole of this one, then what is happening? 2 moles of NaCl will be removed. 2 moles of NaCl will be removed. Here 1 carbon, here 2 carbons. So ethyl group is combined. Methyl. Next ethyl group. Both combined means what we get? Propane we get. Okay. So this is one choice. In the reaction mixture, 2 alkyl halides present means 2 moles of this one can react. 2 moles of this one also can react. 1 mole of this one and 1 mole of this one also can react. So 1 mole of this one, 1 mole of this one reacted means this will get. If 2 moles of methyl chloride reacted, already given the reaction, 2 moles of methyl chloride reacted, what will get? Ethane will get. So this is also possible. Next, if 2 moles of ethyl chloride or ethyl bromide reacted means what will get? Butane will get. Okay, so this is also possible. So ethane will get, butane will get along with propane. So here, odd number of carbon containing alkane also we can prepare, but along with that alkane, mixture of higher and lower alkanes you get. Okay. So if these alkanes also formed means these boiling points, these 3 compounds boiling points are near to same. Okay, nearly same means we cannot separate our required product easily. We cannot separate this compound easily from this mixture. Okay, here you get a mixture of alkane. From the mixture of alkanes, we cannot separate our required product because they have nearly similar boiling points. So that's why this one you will not prefer in the wurtz reaction. To prepare a number of carbon containing alkanes, okay, we will not use the wurtz reaction. Okay, so wurtz reaction best used to prepare even number of carbon containing alkanes. Okay, simple example, one more we discuss in this. If suppose CH3CH2 Br, CH3CH2 Br. If you take these two, one ethyl bromide, one propyl bromide, then what compounds will get? How many possibilities will get? Okay, different alkyl halides are reaction with sodium metal in the presence of dry ether. How many possible alkanes will come? That is a question. How many possible? 3 possible. Okay. So here, if first suppose these two combine means pentane will get 3 carbons or 2 carbons. 3 plus 2, 5. So pentane will get. Here 2 moles of this one combined, 2 plus 2. So 4 butane you get. Okay, next here 3 carbons are there. So 3 plus 3, 6. So it will get a hexane you get. Okay, so in this way, if you take the two different alkyl halides, okay, we can get mixture of products. How many different mixture of products will get? Three different mixture of products will get. Okay, so that's why to prepare a number of carbon containing alkane, we will not use the Wurtz reaction. Okay, by using Wurtz reaction, we can prepare only symmetrical alkanes and higher alkanes. Higher alkanes means double the number of carbon containing alkanes. Initially, one carbon containing alkyl, if you take two carbon containing alkane, you will get. Okay, this is about Wurtz reaction. Okay, so decarboxylation. Decarboxylation means simply removal of that CO2 group. Okay, from the carboxylic acids. From the carboxylic acid, if you remove the CO2 group, what you get? Alkene you get. That is only decarboxylation reaction. Okay, so if you take the sodium salt of carboxylic acid or COONA and heating with soda lime. So here you have to take CaO. What is the use of CaO? Okay, generally this NaOH is hygroscopic in nature. Okay, so easily it will absorb water. So to make it dry, you have to take the CaO. Okay, so this sodium salt of carboxylic acid and heating with NaOH in the brains of CaO. What is happening from this COONA onwards up to this NaO? This part will be removed as Na2CO3. Okay, this part will be removed as Na2CO3. Then which left here? Hydrogen left. This hydrogen, if you add to the R, what will get? RH will get. RH means alkane. RH means alkane will get. Okay. So here initially in this compound, one extra carbon is there. This carbon COO is also there. This carbon is removed. So one carbon less alkane will get. One carbon less alkane will get. First suppose if you take the CH3COONA, in this sodium acetate, how many carbons are there? 2 carbons are there. This are heating with NaOH. This are heating with NaOH. Here what is happening from here onwards up to this NaO, this part will be removed as Na2CO3. This is the common product in all the decarboxylation reactions. Here except here CH3. To the CH3H is added means it will become CH4. Okay, CH4. So by using this reaction, we can prepare methane. By using this reaction also, we can prepare methane. By using Wurtz reaction, we cannot prepare methane. Okay. So by using this reaction, we can prepare the methane. Okay. Like if you take the CH3, CH2, COONA and react with the NaOH. What is the product? Okay, this easily you can write. Okay, from COONA onwards, from here onwards up to this NaO. This part will be removed as Na2CO3. Later this H only you have to add to the last carbon. Then CH2 will become CH3. So CH3. So ethane you will get. Ethane plus Na2CO3 you will get. Okay. If suppose sometimes they give, for suppose they give propane. CH3, CH2, CH3. Okay. Sometimes they'll ask question. Okay. The given reaction, propane, in the decarboxylation reaction, propane will come. Okay. What is the starting salt? They'll ask. Here the 2 carbon containing alkane came means here 3 carbon containing acidic salt. Here 3 carbon containing alkane came means 4 carbon containing acidic salt you write. So 4 carbon containing acidic salt means CH3, CH2, COO. This is are heating with NaOH, sodium butanoate. This is a sodium butanoate. This are heating. What will get? Propane will get the decarboxylation reaction. If you take sodium formate. Okay, sodium formate. If you take here, what is happening? Here from COO. Na onwards up to NaO will be removed as Na2CO3. Okay. Here this H will be added to this H, then what will get? H2 gas will get. H2 gas also will get in the decarboxylation reaction if you take sodium formate. Okay. So in this decarboxylation reaction, one carbon less alkene will get. If you are getting propane, here it will be butanoate. If you are getting butane, here it will be pentanoate. Okay, so in this way, if you are getting hexane, heptanoate, like that. Okay, right. Five completed. Now sixth one. Sixth one, very very important one. Coal-based electrolysis. Coal-based electrolysis. In this coal-based electrolysis, what is happening? Here also you can take the salt of acid. So sodium salt of carboxylic acid or potassium salt of carboxylic acid. Any salt you can take. So this salt on electrolysis. This salt on electrolysis. Subjected to electrolysis. Alkane will get, CO2 will get. Okay, 2 moles of CO2 and 2 moles of NaOH and H2 will get. Okay, these two will get at the anode and this one you will get at the cathode. This one you get at the cathode. If you see one example reaction, CH3COONA, 2 moles of CH3COONA on electrolysis. Electrolysis, what you get here? Here R is a CH3. R you got means here what you get is CH3 will get plus CO2 will get. Okay, plus CO2. Later NaOH plus H2 will get. Okay, here CO2, NaOH, H2, these are common products. Okay, so it is a different one alkane. Okay, so here if you take 2 carbon containing alkane, 2 carbon containing, if you take 2 carbon containing acidic salt, 2 carbon containing alkane will get. Okay, right. Here what is the mechanism? How this reaction is happening? This is important here. Mechanism. Okay, so in the solution, two salts are there, CH3COONA. One is H2O. These two are dissociation. One salt, water. So both are dissociation. What they give 2 moles of acetate ions plus 2 moles of Na plus ions. Here 2 H plus ions, 2 OH minus ions. Okay, so in this way H plus ions, OH minus ions will come. Okay, right. Next, here what is happening? At anode. Okay, at anode. To the anode, which ions will come? Negative ions will come. So negative ions will come to the anode. CH3, C double bond O minus. Minus means 2 electrons. Okay, so why? Because already 1 electron belongs to the oxygen atom. The extra electron gained, that's why minus charge. Okay, so here the extra electron lost means 1 electron will be lost. The extra electron removed. Then what will get? CH3 CO dot. Okay, here we have 2 ions. So if you take 2 acetate ions, 1 acetate ion will lose 1 electron. 2 acetate ions means they will lose 2 electrons. So 2 free radicals will get. Okay, so these 2 free radicals here when they heated in the presence of sunlight, it will undergo homolytic fission. So by breaking this bond, this carbon, this methyl group will take 1 electron, this carbon will take 1 electron. Then what is happening? C double bond O dot, here also C dot. Here these 2 dots combined means it will be removed as CO2. From 1 molecule, 1 CO2 means from 2 molecules, 2 CO2 will be removed. Then here what left? 2 CH3 dots. Okay, 2 CH3 dots left. In this way, 2 CH3 dots are forming. Okay, 2 CH3 dots. So this is 1 CH3 dot, this is 1 more CH3 dot. These two combined means what will get? CH3 will get. In this way, methane is forming at anode. Okay, and CO2 is also forming at a anode. At cathode, what is happening? Okay, so to the cathode, positive ions will come now. So 2H plus will come. So 2 electrons released at anode, those will be gained by 2H plus and it will be removed as H2. Okay, so 2H plus are converting into H2 gas. Okay, now in the solution, the solution 2 Na plus ions, 2 OH minus ions left. Here 2 Na plus 2 OH minus ions. So these two combined means 2 moles of NaOH will get. 2 moles of NaOH will get. Okay, so this is strong base. So here base is found means what is happening? The pH of the solution will increase. Okay, so base pH values for 7 to 14 or 7 to 14. So that's why during the electrolysis, the pH of the solution will increase due to the formation of strong base. Very, very important question. Next here, if you take one example, CH3, CH2, okay, COONA. Okay, COONA. These are electrolysis. What is the product? Here what is happening? This CO part is removing as CO2. This radical we are getting one carbon less radical will get. One carbon less radical will get. Here if you take the sodium propionate. Okay, sodium propionate. This COONA will be removed as CO2 and NaOH H2. This part, this ethyl part, the remaining part is this ethyl part. Two ethyl parts will combine. Then what will get? CH3, CH2, CH2, CH3. Okay, so two free radicals you are getting. These are the free radicals. After COO, remaining what alkyl group is there? Okay, so in that how many carbons are there? Double the number of carbon containing alkene you get. The remaining products are 2 moles of CO2 plus 2 moles of NaOH and H2 will get. Okay, so in this way, any sodium salt or potassium salt given also, we can write the alkane. First, suppose one more example we will discuss. Suppose CH3, CH, CH3, CH2, COO, NA they given. Okay, so 2-methyl butanoic acid, 2-methyl potassium salt of butanoic acid they given. Then this on electrolysis. Here also after CO you have to break this alkyl group. What alkyl group is that? That you have to write 2 times. Okay, that you have to write 2 times. Then what will get? CH3. Okay, CH3, CH2. One more alkyl group. CH2, CH3. Okay, CH3. So these two you have to combine. Then what is happening? This compound will get remaining products are these three CO2 and NaOH H2. So in this way we can prepare the alkanes from a